Hi YouTubers, this is the Celtic Engineer, and today we're going to talk about the SF-5 DAC or digital to analog converter. That's this board right here, and it's based on this chip which is made by Microchip. It's a 12-bit MCP4725. So what we're going to do today is we're going to talk about how to hook this up, and we're going to talk about the firmware, and then we're going to go over just a short project that I did with this that comes with the firmware that you can play with. So there's 5 wires that connect the board to the Arduino. The first one is the power. In this case, we're hooking power and ground to the Arduino using the 5 volts. So there's 5 volts. Then the next 2 wires are the I2C bus, SDA and SCL. The 4th wire is the output, voltage output wire, and the last wire is the ground wire. Now all this information is in the data sheet that comes with the board when you buy it. There's a data package that comes with it that has the manufacturer's data sheet. The board is manufactured by Celtic Engineering Solutions, and they have a data sheet that goes with this. So let's go ahead and talk a little bit more about what we've got on this board here. So it's a little bit messy and hard to see. So I'll just describe to you. There's 2 resistors that go on the SDA and SCL lines, the I2C bus, and these are just 5K pull-ups. You may have to play around with the value of those resistors depending on how long these wires are. If they're fairly short, 5K is fine. If they get to be longer, you may have problems communicating and you'll need a stronger pull-up, which means a smaller resistor. The other thing I have on here, and we'll talk about this later, is just an RC circuit, and we'll talk about that at the end when we talk about the project. So let's go ahead and take a look at the screenshot of the firmware. So this is the firmware that comes with the example firmware that comes with the board, and when you compile it and send it to your serial monitor, or send it to your board, to the Arduino, you'll see on your serial monitor this menu pop up. And I've opened the serial monitor, I've connected it at 9600 baud, and it says digital to analog converter, SF-5 main menu, and there's 7 things that we can do here, and we're going to talk about all of those today. So the first thing we can do is read the registers in the DAC chip. So let's go ahead and do that. And what we can see is it returns what the command byte is, what the DAC most significant byte, least significant byte is, and then what the EEPROM most significant byte and least significant bytes are. All of that information is available, what those bytes are, how they what they mean and how to use them. You can get more information from the manufacturer's data sheet that will be in your data package. But we'll go through some of that now. So let's go on to number 2. What is the power down select? And this is when you put the DAC to sleep, what mode does it go into? So what we're going to do most of the time is we're going to use normal mode, which means it's asleep until you tell it to collect or to output data, and then it wakes up and it does that and it goes back to sleep. If you go into any of the other sleep modes, what it does is it connects the voltage output either to a 1K, 100K, or a 500K resistor. And the numbers in brackets here are the mode, and then they may be different from what you select, 1, 2, 3, or 4, your option on here. I don't know if that's a little confusing or not, but that's just the way that they numbered it. So we're going to go ahead and we're going to use normal mode. So we'll select number 1 and hit enter. Then we're going to select our command mode. So we'll go to number 3 and enter. And we have 3 options for the command mode. most of the time you're just going to write to the DAC in what I like to call normal mode. That's this mode 2, and that just sends a word to the DAC. It converts it to a voltage and puts it out. The reason that you might use the fast mode is if you were going to send maybe 100 numbers very quickly in rapid succession to the DAC, then you would want to do the fast mode because it gets rid of some of the overhead on the I2C bus and allows it to transfer faster. The third way is to write to the DAC, but also write to the EEPROM. And what this does is it stores in the EEPROM the value that you want to be output on the output voltage line when the unit powers up. It stores the command mode and the power down select modes. So all of that is written to the EEPROM. So we're going to just select number 2, which is the normal mode. And now we're going to get started with actually writing some information out to the module itself. So let's go ahead and change screen modes so that you can still see on the left here the command prompts, and on the right you should be able to see what we've got going on here. Mostly what I want you to be able to see is the voltage monitor. So let's go ahead and we're going to write a value. We're going to get a value to write. And so what we do is we select number 4, and then it says enter a value between 0 and 4095. You must use leading zeros. So you have to put 4 characters down. Even if it's less than 1,000, you have to put a leading 0 in there. So let's go ahead and let's just start with 2048, which is mid-scale. We'll put that in, and nothing has changed because we've just written that value to memory. Now we're going to select number 5, which says execute a write. So we're actually going to write that to the DAC, and if you watch the DVM, you'll see that it should go to about mid-scale. Okay. So let's go ahead and put another value in here, and this time I want to put in 500, but I need to put 4 values, so I'm going to put 0500 and then hit return. And then we're going to go ahead and execute a write, which is number 5, and you'll see that we're going to go from 2.5 volts to about 0.6 volts. Okay. So let's do one more. We'll go ahead and do full scale, which is 4095. And it automatically ran right through and did that. I must have held my finger down too much on the enter key. Either that or there's a bug in the code. We'll have to check that before we get it out to you. Anyway, so those are the ways that you can write to the those are the ways that you can put a voltage out on the output voltage line, and you can set things up. And for the most part, that's what the software does. I did an extra project that I just thought was fun and you might have some fun with, and it's a sine wave output. And so what I'd like to do is we're going to go to a different view here. So this is the oscilloscope, and right now you can see that it's not connected. So let's go back here, and I'm going to connect first to the raw output signal. And you can see that we're at 5 volts, and you can see there's a little noise on the line. I'm in the video recording studio and I'm not at my lab bench, so I think we have some maybe some ground loops or some ground noise that's causing us to bounce around a little bit because I don't see this when I'm at the lab bench. So let's go ahead and I'm just going to go ahead and show you what happens when you select number 6, which is sine wave output, and it gives you some information. It says that it's going to do a sine wave output, and if you're in that output and you would like to exit, what you want to do is you want to hit the E key, and that will exit out of this. If you hit the plus key, it will increase the period by putting a delay in there, and if you hit minus, it will decrease that period. The number of delays, and delay is the millisecond timer in the code. It'll be printed on this screen right here down on the bottom. Here, let's just go ahead and I'll go ahead and hit a plus and hit enter, and I hit plus again, and then I can hit minus, 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 and you can see it'll tell you how many delays you have. We'll go to the we're going to go to the oscilloscope next, and you can see what that effect has on the signal. Now, the way we're generating the sine wave is we have a 32 entry lookup table, and so that's why you see these stair steps, is there's 32 steps in here, and it looks like kind of like a sine wave. It's a little bit crappy. It's not the best thing in the world, but we're looking directly at the output, and this is what it's putting out. So if we put a little bit of filtering on this, and so let me just switch you back over so you can see what I'm doing. I'm just going to go to the other side. Instead of the raw output, I'm now going to go through an RC filter and go back, and now you can see that just going through a simple RC filter, we get a much cleaner looking sine wave, and the frequency is about 92 Hertz, and that's the fastest that the Arduino Uno can produce a sine wave using the I2C communication bus to the DAC module. So now I'm going to go ahead and I'm going to hit plus and put a delay in there, and you can see the effect that it increases the I'm going to adjust the time scale, and it increases it decreases the frequency, and you can see we're now at 23 Hertz. And I'm going to go ahead and hit plus again, and now we're at 13 Hertz, and we hit plus again, and it drops down to 9. It's not linear because it's putting in a millisecond delay after each after writing each value, and so each time you do this, it adds 32 milliseconds to the entire wave each time you hit plus or minus. We'll go back to the screen, and you can see that we've gone, this is where I was showing you going up and down, and now I've gone back up to 3, and you can see that's now about 9 Hertz. You can increase the delay up to 256, which I think is I want to say 8 seconds, 8-second period. But you can play around with that. I hope you have fun with it. I hope you have fun with the module, the DAC module, and do great projects with it. If you do something fun, please write us about it in the comments below so that we can know what you're playing with and what success you've had, and we hope that you have a lot of fun with it. And we look forward to hearing your feedback. So have a great day.